Thanks, Shannon. I'll introduce myself. I am not Natalie Stingelin. She's in Mexico right now. I am not Carlos Silva. He's homesick. Again, Seth Marder. And a couple of hours ago, I was asked to say a few words on Natalie's behalf. And so, as I said, we're part of a team, and the team covers a lot of different things. Natalie is a materials scientist. She's a polymer physicist. Okay? And she studies organic materials. One of the materials that she spent some time understanding is chocolate. And she can tell you why Swiss chocolate, being from Switzerland, Natalie is far superior to British chocolate. British chocolate crystallizes in the wrong polymorph, the wrong crystal structure, whereas Swiss chocolate is perfect. Okay? So she does those kinds of things, but what she's also working on are hybrid materials. Okay? And what she has invented is a way of making very thin alternating layers of organic polymers and inorganic materials that have very different refractive indices. And so when you do that, these things, if you build up multiple layers of them, could be made into extraordinarily effective but transparent reflectors. They can be reflective at one given wavelength and transparent at others. And so what Natalie has done, among other things, is to develop these things which reflect infrared light, but transmit visible light. And so if you imagine coating windows with that, okay, in the winter, they would reflect in the heat, okay? And in the summer, they would reflect back out from the outside the heat. And in this way, they can help manage the thermal load of a building. So these things can be used for residential areas. Shannon already explained that we spend a huge amount of money on heating and cooling, okay? He said 15% of the total energy that we expend is on heating and cooling. Something like 30% of electricity is spent on heating and cooling. If we can improve the efficiency with which we reject heat from the outside in the summer, keep heat in the winter, that can be quite significant. Moreover, these things can be incorporated into things like greenhouses and make greenhouse technology in various places, not only in the United States, but in, for example, arid lands where evaporative problems are large. If you can keep those things cooler, okay, they can be more effective. Natalie develops these materials, and now she is working with many people, including Shannon, okay, to incorporate these materials into systems that can be used. I think the last thing that I want to mention here is that the thing that has made us very effective and makes us sort of plug and play for working with various different teams is that as a team, we talk to each other a lot. We spend the time to talk to each other and learn from each other. Georgia Tech has gone after many large proposals for centers, and we don't succeed quite as much as we would like. I think that is a safe statement. And people have asked me, because I've been involved in many centers over a long period of time, why is it your team is my team, the team that I'm part of, is more effective at getting these than many others? And I think the answer boils down to the time we spend with each other to learn about what each other are doing. And I just want to leave you with the fact that, in my view, there's no substitute for that. You can't circumvent that. And so if you wait till a call comes out for a large proposal and you put a team together, your chances of success are less than if you get to know each other earlier. And so in that regard, what Michael is doing here today is a very good step along that path. Thank you.